All right, today we're going to work through our new Drosera workshop. You can feel welcome to follow along with me, and we're going to work through back to back. We're just going to hit workshop 1, workshop 2, and workshop 3 together. And through these, you will see the full life cycle of developing traps with Drosera, with the Drosera Trapper CLI, as well as running the operator that actually executes the traps. And we will actually see traps executing on-chain response functions. And at the end, you will have submitted your Discord username to a contract that is deployed on Haleski Ethereum, which will get you a special cadet role in the Drosera Discord. So let's kick things off here. I will post this link in the video description so you can get that there. And let's just check out the outer README here. If you've never worked with Drosera before, then you can simply run this command, and this will install Drosera up. And if you have any extra issues in this department, let me just go over to our docs here real quick. Let's go to start trapping. And this is this command here, installing Drosera up. And then once you install this, you can simply run Drosera up, and it will install the latest binary of the Drosera Trapper CLI, referred to as Drosera, and the latest version of the Drosera Operator CLI, which is called in the terminal Drosera-operator. And I believe you'll need to have Foundry up as well, so you can come in here and just run through this page if you've never worked with Drosera before, and install a couple binaries, Foundry, and then you don't need to do this for today. If you want to do your separate project, that's fine, but you can skip that because today you'll start with this repository, so you can just come in here and clone this, open with GitHub Desktop, etc. Okay, so once you have this installed, we need to run bun install. And now let me go over here. I have the this Drosera Workshops repo downloaded locally here, and I have my terminal set up over here. I'm in the top level Drosera Workshops. So the first thing I'm going to do is we're going to install our dependencies, bun install. This is similar to an npm install. So bun install, let's run that. Great. A couple packages installed. We can see we have a node modules here now, so we're good there. Let's check our next instruction. Okay, so for each workshop, you may need to update the trap path in the Drosera.toml file to point to current workshop build files. Okay. You will need to add the operator address to the whitelist in the Drosera.toml file to opt into the trap. Okay, so we'll get to that. And build commands. Okay, we have a make file with a couple like wrapper commands, making some of this easy for you. So if this is your first time doing any of this stuff with Drosera, these are great options to get started. And then once you understand what's going on, you can go further down and look at the underlying commands and the arguments and understand how everything is coming together. So first we're going to run make build workshop 1. Now we can just see here in our make file, make build workshop 1, and this essentially just changes directory down into workshop 1, which is what we're going to complete first before we do 2 and 3. And then it runs forge build, which just compiles the trap solidity code. So these need to be run from the top level though. So I copied this, make build workshop 1 from the top level here in Drosera Workshops. Okay, and compiling, and no files changed, compilation skipped. Okay, I may already have these compiled actually. Let's just double check. Workshops, workshop 1, okay, out, and there it is, Trap.sol, trap.json. Okay, yeah, so the trap is actually compiled already. So, and that is this trap right here. Here's our actual trap that we're going to be using in workshop 1, and we can see we have our collect and should respond functions, as every trap does, and the collect function is simply collecting data, each block from the chain, so collecting state data. And so every block, when an operator is running this trap, it's going to call collect at least one time. And here it is simply going to the response contract we have hard-coded and predefined here. And by the way, this contract is already deployed on Husky Ethereum, so feel free to use this. You don't need to change this address. This will work. And it has a function on it called isActive. So we'll see true or false if this response contract is active, and we simply return this data out of the collect function encoded. Then once the operator is called collect, it will take the output of collect and it will pass it as the input into should respond, where we write our logic deciding if we should return true or false. And if we return should respond returns a true value, then the operator is going to say, yes, we should go execute the defined response function, which is a great time for me to show the Drosera.toml here. This is your core configuration file for when you're working with traps. We have a few top level fields, like where's your Ethereum endpoint you want to use, how to connect to Drosera, and the address of the Drosera address on Husky itself. If you don't put this, it will use a default version. It should map to this based on the Ethereum RPC you use and the chain ID that it's able to derive from this. Then we have a trap section, so this is the real meat and potatoes here. So I have one trap in here so far, and I'm setting the path to where the actual compiled trap code is. So that was what I showed earlier, going into the out folder Trap.sol.trap.json. Then these are probably maybe the two most important in here, and that is if this trap does, in a given block the should respond function returns true, it will submit a claim to go call this response function on this response contract, and this is actually happening on chain. Okay, so let's go back to our trap here. So we take the data that we get in should respond, which was the output of collect. We decode it. We know it was a bool. That's what we encoded. That's how we're decoding. If the response contract is active or not. So if the response contract is not active, then we are going to return false, aka do nothing. And then we can also choose to return some data out here, and this data, if you do pass it, is what will be passed in as arguments to the response function. So this respond, it has no data, so there's nothing for us to pass here. Now, if the response contract is active, is true, then we're going to return true out of should respond with no information, because we don't need to in this case. And this will say, hey, go call the respond function. Okay. Now I want to make another point here. Min number of operators. This is the minimum number of operators required to trigger the trap. So in these workshops, I'm going to be the only operator running this trap, and so I have it set to 1. So even though it's only me, I'm still able to come to consensus and execute the trap. Versus if I had 10 operators, for example, then I would need to come to a 2/3 majority consensus. 2/3 of the operators running the trap having a should respond value of true in order to successfully enact the claim, go execute this response function on chain. Okay, I'll just cover a couple of these other ones. So yes, we can have a max number of operators as well. Cooldown period blocks, how long to wait before the trap can be triggered again. Depending on what kind of trap design you have, it could be triggering a lot, so maybe you want a cooldown function. Okay, another very important one, block sample size. How many blocks to sample to determine the price of the trap? So I have it set to 1 for now because we're literally just checking, is it active like in this block? And so since it's equal to 1, the operator on a given block, it's going to call collect only one time because block sample size is 1. So that's how many times to call collect, because should respond gets an array of data here. So you can call collect multiple times, each over a different block. Say if a block sample size is 10, I can call, the operator will call collect for, say the current block number is 100. The operator will call collect over state data from block 91, 92, 93, 94, 95, 6, 7, 8, 99, and 100. So you have multiple, the same call over multiple iterations of state data, of state, and so you can see what's changing between. So you can do like time series analysis over prices, etc. But in our case, we're just testing this Boolean is active function, so we don't need more than just one block's worth of information. Okay. And then private trap. If this is false, then the only operators able to run this trap are professional operators that we have already whitelisted. But if this is set to true, then the only operators able to run this trap are those that you explicitly define their addresses here in the whitelist. So we don't have any there right now, but we'll get to that. Okay, that pretty much covers that. And I'll just show the actual response contract. So this contract right here, this is the actual contract that's deployed on chain. So here's the is active, so it just returns a bool. And then if our trap does get triggered, should respond returns true, then it will go call respond on this contract. And we can see here respond essentially says that this specific user address did in fact respond. So we'll be able to see that if you are a responder or not, true or false. So we'll get to that at the end. Okay, great. So let's actually get to this now that we're past some intro explanation. So let's check out the README specifically on Trap 1. So I've installed my dependencies and I built the workshop. Let's go down here into workshops, workshop 1. Okay, so in this workshop, what we're going to do is run basic commands to deploy a trap. And essentially, really what that boils down to is the most important command in the Drosera Trapper CLI, which is the apply command. All right. So make sure to build the contracts before running the Drosera command, so the updated bytecode is used. So we already ran make build workshop 1, which did a forge build, so we're already good there. Now we're going to test the trap before applying it to the network. So let's run the dry run command. This essentially tests one life cycle of like trap execution, like over one block, on like a local ad hoc spun up operator just on the fly. So if you have any compilation issues, you'll see these with forge build. And so if this build's fine, your trap code is fine. But maybe you have a runtime issue with your trap, and that's what will get picked up here in dry run when it actually tries to run it. So let's double check our Drosera.toml. So dry run is going to work. It's going to work with this. I'm running it in the same folder as my Drosera.toml, and it'll automatically find this file. And then the code the trap it's actually going to run is what I have defined here. So I'm making sure that I am set to workshop 1. Okay. So now let's run Drosera dry run. Okay, collecting our blocks, and we successfully executed one iteration of this trap. And again, we can see my trap and my trap. This is an arbitrary name. You can name this whatever you want, just for organization purposes. The trap's not deployed yet, so it's just an all zero address here. And so we can see should respond return true, which means the response contract is active at the moment, and it ran this over block 3,943,127 on Haleski, and we can see that it returned no response data as we expected. Okay, so that's working. So now let's go ahead and apply the trap to the network. So this is a brand new trap, so right now with apply we're going to create it. Apply is a smart command. It can tell if it's a new creation or if it's an update of an existing trap, and we'll get to that in workshop 2. But for now, let's run Drosera apply. And I just want to, if I forgot to mention here already, if you're running some of these commands, I've set my private key with a .env rc file. I have an example.env here as well, but I highly recommend you set up an env rc file for the best experience with this. And there you can follow an example here, setting your private key and such. Okay, so let's run Drosera apply. Okay, here we go. Something I forgot to do. Okay, so it failed during its apply config, failed to plan config. Okay, invalid number of operators. So the reason we're getting this error is because I have set this private trap as true, but I didn't give it any whitelisted operators. So if it's a private trap, it needs to have at least one whitelisted operator. So I'm going to whitelist my address that I'm using for my operator. Let me copy and paste this in here. Okay, inside some quotes. There we go. Let's go back. I'm going to try this again. Okay, great, we're working. Okay, so the apply command actually bundles some other Drosera commands in at the beginning. So if this looks familiar, that's because the apply command is essentially running the dry command inside here. And then it's running the Drosera plan command, which I didn't show. Maybe I'll show it after this. And you can see that plan determined that this is a new trap, so it's going to be a create, not an update for my trap. With a gas estimation, and then we got a couple pieces of information. This is all from the Drosera.toml file, and you can see here highlighted is our response contract and our response function. So if the trap is triggered, it's going to call this respond function that's on this contract. And here I am in the whitelist. Okay, on testnet, it doesn't require any tokens to deploy at the moment, just for testnet purposes, but this will in the future require some tokens for creation and updates. All right, so do I want to apply these changes? Yes, but here we say of course. All right, so now we're going to execute, send that transaction up to the chain. This creates a trap config on chain managing core trap information, and then it sends the trap bytecode that's not stored publicly, that gets stored on a seed node. Okay, great. So now, and most importantly here, it gave us an address 0x3356. So I want to just go show you now. After we ran that command, it automatically updated our Drosera.toml file. So for our my trap, it added this address here for us. So if you see an address here on a trap, that tells you that it exists already. If there's no address, then that should mean that it doesn't exist yet, okay? And now no matter how many times I update this trap, this address is not going to change, okay? And this address is the address of the trap config contract that is actually deployed on Haleski Ethereum, okay? So that is great. Now, what we're going to do is test if the trap has been triggered and has called the respond function on the response contract, essentially like testing if things are working here. Okay, so 70D1, I'm just double checking. That should be this. Yep, okay, so that's this response contract address in this forge cast call. We're going to call isResponder, and we're going to pass our address. So this needs to be, we can check if the owner has responded by calling the isResponder function on the response contract and pass in the trap config owner's address, okay? And that's going to be the same address that I've been running, that I just deployed the trap with. So whatever private key whatever key pair you used in your environment file, or you can pass a private key directly in the Drosera CLI as well. But that key pair, that's the address you need to put here, and then you just need to put your RPC URL. This is a free one. If you use it too much, you'll get rate limited, so I recommend getting a free Alchemy one. But I already have this for myself written out down here. Let's see. Okay, let me get my address. I think I already upped it. 56CA. Okay, great. Copy this. So I'm going to go run this that's updated with my address. So you need to update with your address that you're using for the Drosera CLI here. And then you can run this. Okay. And I get a false back. Okay. That means I haven't responded yet. The trap hasn't triggered yet, essentially. Now, why is that? You may have been thinking, oh, we deployed the trap, so it should be running, right? Well, not exactly. For a trap to actually execute, we need two things. The trapper needs to deploy the trap to Drosera network, essentially, and two, at least the minimum number of configured operators must be opted in and running the trap. Okay, so in this case I have it set at 1, so I need at least one operator that has opted into this trap in order for it to be triggered, which could be said another way, in order for a consensus to happen. So that leads us to the next part here. So let's go ahead and run our own operator, and we're going to run the trap that we just deployed. So I'm doing this with a new key pair. So if you need to register your key pair as an operator into the Drosera contract before we can actually go do anything with it. So I'm going to copy this, and this actually runs a command under the hood, but these make it easy for you to get started. So I have another tab over here for operator stuff to keep things separate, because I am going to be running an operator binary that will take up this terminal, so I recommend just making a second window for this. And now I'm going to go register the operator, and again this is pulling, this is registering my key, and it's pulling from my .env.rc file where I have Drosera private key configured. So you can set your own private key in the same way. Okay, and so you can see here under the hood, under this make register operator, it actually is running the Drosera operator binary with the register command and a couple pieces of information. Okay, so we registered our operator's BLS public key into the registry, and the operator is now registered. Great. Now let's go opt into this trap. Okay, so here's another make command. This one I do need to edit. I go back here, opt in. Actually, so it's running the Drosera operator binary with the opt-in command. Now I do need to manually configure what's the trap config address. So the trap config address is this address right here, which again is the same as the address right here that it showed when I deployed it the first time. Okay, so I'm just going to copy this address. This is the trap config address. Where was I going? Okay. Make file. Alright. Update this. So when I call make opt-in, it's going to opt my operator in to this trap, which is the one we just deployed. Okay. Make opt-in. I saved this. Okay, so let's go over here. I'm gonna run make opt-in. It's opting into my trap 0526. Double checking 0526. Okay, we're all good. And
what's up, Jake?
oh, hold on, I'm in the middle of recording a video. All right. Whoops, someone hopped into my digital office. Good thing we're still recording. Okay, so opt-in transaction successful. So now we should be able to simply run the operator. Okay. And to note at the beginning, we can see number of opted in traps, 1, which is exactly what we would expect. This is a brand new key pair. I just opted into our first trap that we just deployed, and so that's what we see. The operator is going to have some startup logic. It's going to take a second to get going, and then we'll see a big blob print out, successfully submitted claim. This is actually, the trap was executing. It saw that it was active based on the collect and should respond function, and so it should respond return true, which then triggered the response function to be called. Okay, so now if I go check this again to see if I have responded, we should see something a little different. Voila, and it is now true. Okay, so that is the end of workshop 1. Now I'm going to go right into workshop 2, and we're going to keep this train rolling. Okay, workshop 2. Now this is just going to continue building right off of where we left off. We can just keep going. So in workshop 2, we're going to update our Drosera.toml file to use the new some other response function. Okay, a different response function, the function signature, and a new response contract address. Okay, so let's go update these. So I'm going to copy this and make sure you get the whole thing here. This gets hashed and it has to match exactly. So the name of the function, parentheses, and the data types of any inside. It has to be exactly correct or it will not work. Okay. So we're going to continue working with our same Drosera.toml file, so I'm just going to be updating it. So in workshop 2, to demonstrate that we deployed one trap, and now I can customize it and update it and keep, it's like a living thing. I can keep changing it. So before I wanted it to call respond if it triggered, and now I'm changing my mind, and now I want it to call some other response function, okay? And this function is actually on a different deployed contract on Husky Ethereum. And so let me close workshop 1. Let me go into workshop 2. Source trap. Close that one. So in our workshop 2 trap, which is, I believe, exactly the same as the workshop 1 trap, except the response contract is a different address. So I'm going to copy that response contract address and replace it here. Okay, so it's our new response contract address and our new function that exists on that. And also the path. We're working with a different trap file now. So I'm going to change the path so it knows where to go get the code. And so that's now in workshop 2. Okay. And additionally, I'm going to run the same command I did before. It's going to build everything. So that's going to be make. Let's find it. That was on the front. That was on this page. The top level README. We have make build workshop 2. Okay, so let's go around that. Build workshop 2. Okay, I guess I already had it compiled, but if it's the first time, you'll see it was compiling files. Okay, now let's go back. Okay, workshop 2. We updated both of those, and now we can, and we compiled, so let's go test our trap now with the dry run command again, make sure it's all working. Drosera dry run. Great, we see it should responded true. It didn't return any data. Fantastic. And now I'll just demo real quick the Drosera plan command as well. This essentially shows you what will happen when you run Drosera apply without actually doing anything. It's just showing you what the plan will be without executing it. Okay, so what changes are going to apply based on our current updates. So my trap, it sees that it already exists because it has this address right here. And so it is updating my trap. And it can see that the trap hash is changing. This is because the hash of the actual trap code is different because it's a different contract. Then I changed the response function, or sorry, the response contract. I changed the addresses. Here's the new, the green is the new one. The red is what it used to be. And I also changed the response function from respond to some other response function. Okay, so you can just see the state change what's going on. Now, so when I run Drosera apply, this runs dry run, and then it runs plan, and then it asks me if I want to execute the plan. So a couple kind of modular commands here. Dry run, we have the same plan. This shows us the seed node DNR changes. We truncate it, so it's actually something in the middle here that's truncated that changed. And this can change from deploy to deploy based on which seed node is the optimal one to deploy to at the present time. But that's not really something you need to worry about too much. The other three are the core, most important, the important ones. So that all looks good to me. So of course, let's see. Get Drosera token address call. Failed. Okay. Did I get rate limited? 429 status is usually a rate limiting. Ah, okay. I forgot I didn't change this. So this is using just like a public free Ethereum RPC. I am going to change this to a better one. So I'm just gonna exchange this out. This is a better one. This is something we've commonly seen in the community, people getting lots of 429 statuses. That usually means rate limiting. They're using an RPC that's not good enough. So I'm just going to try running apply again, and since I updated my Ethereum RPC, it's going to use my better one now, and we shouldn't have that error. Okay, of course. Great. Okay, so we updated the trap. Again, the address stays the same. Okay, so trap is updated. Now, on this new response contract for Workshop 2, we're going to see if we responded or not. Let's see, I have this command down here, 1 second. Okay, copy this. Okay, so we're checking is responder on the 4B98 contract, and that is 4B98 that we have here, that we got from here. Okay, so false. And it seems the operator ran into some sort of snag here. I'm just going to stop it real quick, and then I'm going to restart it. There's no harm in stopping and restarting it. It'll recheck the chain for all of its traps that it's in, and it's kind of like restarting your computer. Okay, you can see we're still on one trap. And it should... did I forget to do something here? Failed to submit claim to network. Reverted data. Hold on. Let me check something real quick. Cooldown active. Okay, I checked our errors map. This actually means the cooldown is active. Oh, there we go. Okay, it's been long enough. So again, that was the cooldown period blocks 33. So since it submitted the last one for this trap when we were doing workshop 1, it successfully submitted a claim, and the operator was still running, and it kept seeing that our response contract was active, so it kept trying to submit claims, but the cooldown wasn't over, so the claims were not going out. And then with this new trap, it was trying to run again, but it couldn't because it hadn't been 33 blocks for the cooldown to finish, and then it just finished, so it must have been 34 blocks now, and it was able to successfully submit the claim. So now, if I go over here, let me go get my command, and again, that's going to be on workshop 2 here. This command, it's the same as the last one, except the contract address we're calling is changed, and you can use your same owner address that you've been using in these workshops. Okay, I already have this written down for workshop 2. So we got false before, now I'm going to run it again, and now we have true. Great. So that is workshop 2. Now let's move on to the finale here with workshop 3. This is where I actually start to do a little bit more. So in this workshop, we're going to, again, update our Drosera.toml file to use the new respond with Discord name. And this time, our response function actually takes an argument. This one is a string. And our new response contract address. Okay, so we've done that before and updated an existing trap. But now what we're also going to do is we're actually going to update the trap code itself so that it has our Discord name that it can respond with and pass as this string. All right, so let's see, we need to compile the code. Now, since we're actually going to go change the trap code, let's go change it first, and then we'll go compile. If I compile now and then I go change it and I forget to recompile, when I deploy the code, when I run Drosera apply again here, it won't have the code with my Drosera username, and so it won't actually submit my Discord name to the response contract, and then you won't get added to the list and you won't get the role. So let's make sure we do it in the right order. So let's go in here, we'll close workshop 2, close that, and let's go into workshop 3 now. Okay, so this contract is almost identical, but we can see here, add your Discord name. We just have a constant for Discord name. I'm going to put my Discord name in here, my Discord username, and the only difference here now in collect, it's not only returning if the contract's active, it's also returning the Discord name. And then here we have a couple extra checks, making sure it'll also return false if your name is 0, so make sure you put an actual non-zero Discord username here. And then if we return true, the response contract is active. We will also return with it our encoded Discord name, which in this piece of data again is what will get passed into as in the response function. So let's go update that. So I'm going to copy this, make sure I get it exactly right, or it won't work. All right, so we're going to update the response function here. We have respond with Discord username string, and then let me get the response contract here for workshop 3, ends in B600E. Response contract, update that. Okay, great. So now I've actually updated this trap code, so I need to recompile this code. So what I can do, easily do this, is run make build workshop 3. Okay, make build workshop 3, and I've already compiled this code in the past, but if this is your first time doing it, you may see compilation. This should be working. Yes, I saved it, so it should all be good. Just a demo, if I put an extra S in here, this should have changed. So if we run it again, there we go. You can see compiling one file. Okay, awesome. So I'm just going to change it back to my actual username. Run this again. It compiles it. Okay, so now I have it the way I want it. Okay, so now we're going to run through the same thing again. We're going to Drosera dry run. Where's my terminal? Drosera dry run. Okay, that looks all good. Okay, response data 0x. Oh, I know what's happening. There should have been a response data. I forgot to update this. It's doing the old. That's the reason why it didn't change. I forgot to change this. So make sure you change to workshop 3 so we're actually pointing at the code that we're changing. Otherwise, you'll make changes and then you won't see any difference in what's going on. So, okay, now I need to rerun. Okay, so so we're good there. Okay, Drosera dry run. There we go. Now I see something here with response data, and this is my encoded Discord username. So that's as expected. Okay, so now let's run our Drosera apply. We're actually going to update this trap on chain. And again, the code changed. I changed response contract addresses. Now we're looking at B600E, and now we're responding with a Discord username and passing in our Discord username here. Of course, let's update that. Let's see how fast Husky is today. Sometimes it gets kind of slow. Sometimes it's really slow. It's supposed to have 13-second block times. Okay, there we go. Finally, that took quite a while. Husky must be running slow today. Okay, so we updated the trap. So we're going to run the same thing again. We're going to check if we responded to this workshop 3 response contract, the B600E, and put the same address you've been using that you've been deploying your traps with. Okay, so I'm going to go check this. I have this command written down below. Okay. So B600E, my address. Okay, false. So let's check out what's going on over here. Okay. I think it is still. Let's just look at some logs here. Enzymer has been shut down. Okay, yeah. See, it found a trap update. I just ran Drosera apply to an existing trap, so it's updating it, and the operator automatically found an update, and so it basically restarts the trap that it's running with the new code, and now it's failing to submit the claim because we're updating this in a soon-to-come PR that actually decodes these properly. But checking this one again on my error mapping here, 748614C3, that is the cooldown active. So the cooldown is still, oh, there we go. Okay, so it didn't take too long. We just needed a couple more blocks. Now it's successfully submitted the claim. So if I go back over here and I run my cast call again to see if we responded, and we are true. So that means my Discord username was successfully submitted to the response contract, and now I can get my new cadet role. Well, that covers it for all of our workshops 1, 2, and 3. Appreciate you coming along. If If you have any issues going through this yourself, I highly recommend you hop in our amazing Drosera Discord server. We have an incredible community, and there's tons of people that will be more than happy to help you, and I'll be in there as well. Feel free to tag me at Jake Rumbles in Discord and ask me any questions. And that covers it for today, guys. Thank you very much. Have a good one.